Hi everyone, this is Group 8 from Section 1. So this video is about the e-service learning of the cost communication principle. So in this video, we will talk about amplitude modulation. So you may ask, what is modulation? So modulation is a process of transforming a message signal into a format suitable for transmission through a specific medium. So we need modulation. So because of cost efficient, for low frequency signals like voice need a big antenna, but modulations allows them for small antennas. And then the second one is allow many users at once. So modulations lets different users communicate at the same time without clashing each other. And the third one is the noise control. So modulations protect the signal from disturbance. So there are two types of modulations. So the first one is amplitude modulation, AM, and then the second one is the angle modulation, which is separate into two: phase modulation, PM, and frequency modulation, FM. So today we are talk about AM. So the concept of AM is the amplitude of the high frequency carrier signal is varied with the amplitude of the message signal. So for the process to work, the carrier's frequency FC must be much higher than the modulating frequency FM. So AM signal consists of carrier signal, upper sideband at frequency FC plus FM, and then the third one is lower sideband at frequency FC minus FM. So this is the graph showing the carrier signal, the modulating signal, and the output of amplitude modulation. So we can see the carrier signal is high frequency, and the modulating signal is lower frequency, and then the output of amplitude modulation is like this. So there are a few variants of AM modulation. So we have AM DSBFC, and then AM DSBSC, and then AM SSBSC.
Information signals such as our voice cannot be transmitted over long distance, since it will lose power easily over distance. Therefore, we need a radio tower with high frequency carrier signal to carry our information signal so that it can transmit the voice further. We can imagine the scenario like we are delivering cookies to customers. The cookie itself is like the information signal we want to send. It is fragile and will broken easily during the delivery process. Therefore, we need to wrap it with bubble wrap to protect it, making it less fragile. Therefore, we could think about the whole modulation and demodulation process like this. The information signal is like the cookies we want to send. During modulation process, we changes the amplitude of carrier signal according to our information signal. This is like we wrapping our cookies with bubble wrap. As a result, our carrier will oscillate within a boundary that looks like the shape of information signal, and this boundary is known as envelope. This is like we have cookies wrapped in bubble wrap. Then, if we want to get back the information signal, we use detector to retrieve it. This is like we use scissors to remove the bubble wrap to get our cookies back. So you might ask about how do we change the amplitude of our carrier during the modulation process? It's basically like this. When we are wrapping cookies, we use more bubble wrap. When we have more cookies, we use less bubble wrap. When we have less, this is like the amplitude modulation process. If the information has high amplitude, then we change the carrier to larger amplitude. If the information signal has smaller amplitude, we changes the carrier to lower amplitude. By doing this, we can recreate the shape of information signal on our carrier, which allow us to retrieve the information signal later by the detector. So it's a wrap from me. Thank you.
For generating a signal, we need a modulator. Like we mentioned just now, as you can see, we have two signal source, which is our measure signal and also carry signal. And here is the result of modulator. As we can see, the blue line is the measure signal, and the green line is the carry signal, which is like our bus, and the blue line is like the passenger. So the carry will send the passenger to the receiver. Then in receiver, we will receive the message, but we just want the measure signal, which is our passenger, and now we need to remove the carry signal, which is our bus, by the low pass filter. Now we can see in the receiver, we just have the blue line, which is our message signal, and the carry is already removed.
Good day, everyone. Today I'll briefly talk about the impact and benefits of amplitude modulation in communication systems. Amplitude modulation, or AM, was one of the earliest modulation techniques used in radio communication and played a major role in enabling long-distance transmission of voice signals. Its simple design made it easy to implement, especially in early broadcasting and aviation systems. Although AM is sensitive to noise and not very power efficient, It remains important because of its wide coverage and reliability over large areas. One of its key benefits is the low cost and simplicity of both transmitters and receivers, which makes maintenance easy. Even with modern digital techniques available, AM is still used today due to its simplicity, compatibility, and effectiveness in basic voice communication. Thank you.